Welcome back to part 2 of our series where we are building a random forest model to help predict the price movements of a given stock. So in our last video, we kind of introduced the whole topic of random forest. So hopefully now you have at least somewhat of a high level understanding about kind of what random forest is, what it's trying to improve upon, and kind of the building blocks of basically the building blocks that are needed in order to create it. So that was the last video. We also talked about just some of the problem context. So all of the video that you're going to be seeing over this series is basically replicating a research paper that I found online that utilized random forest to predict the direction of a stock. So pretty interesting stuff. And like I said in the previous video, I will be posting everything related to that research paper on GitHub. And I do encourage you to, if you want, take a read through it. It's kind of interesting. Some stuff you don't need to really go over that much, but it's there for your resource if you want to kind of say, okay, I like what they were doing there, but I don't like so much what they were doing there, and all that kind of fun stuff. Gives you a nice framework on something to improve on. So now that we have our context, we're going to go through the process of actually starting to code. So the first portion, I would say most of this code's already pre-written, so I'm just going to kind of go through it a little bit, and give you some context as to why it's there and what it's supposed to be doing. And then I would say probably more towards the end of this video, we'll get more into the actual coding it kind of by hand. So the first thing I do want to go over is the libraries that we're going to be using. Some of these don't think I'm actually using at any point, but when I was initially testing it, I was. So I think request, I don't think we need that one. System, you probably will need, and then OS. So this is all stuff related to paths. You'll see in a second, we're going to leverage the TD API client I built. And so that one, in order to leverage it, we are going to have to create a system path. Additionally, we will be using Pandas and NumPy a lot. So this is all going to be used for calculation purposes and just taking our data and making it nice and organized and in a nice structured format. Then additionally, we're going to be doing some plotting as well. So we need to make sure we have matplotlib at our hands if we need it. Additionally, we are going to be using the scikit-learn library. So for those of you who are not aware, scikit-learn is basically a machine learning library that is very popular in the Python world, and you can do all sorts of different types of machine learning models with this particular library. And on top of utilizing those models, you can also do things like certain scoring metrics, so it does all those calculations for you, even graphing now in some of the later versions of scikit-learn, and then just things where it comes to actually improving your model and stuff like that. They give you a nice, good tool set for you to leverage it. Just an FYI, this line in particular right here, so plot ROC curve, that is with the latest version of scikit-learn, so I'm sure some of you probably will get an error when you import that. If you do get an error, just make sure to upgrade your version of scikit-learn to the latest one, and everything should work fine. Additionally, there is this kind of last line here. For those of you who are not used to working with config files, a config file, at least in our term, is basically just a Python file. So if you actually go here, you will see a config.py file. And inside that config.py file are a bunch of variables that contain information about my account that I need to use to log into the client. So all that config file it's just a Python file with those variables, and those variables have some information attached to them. So if you run this code and you do not have a config file in the same exact location as this Jupyter Notebook, you will get an import error. If you create a config file and you do not name these variables exactly the same, you will get an import error. Now, you can technically change this. You can make it all lowercase. You could remove, the underscores and make it all one word. That's fine. But if you change it here, you need to change it in the config file. So it's very important that you do that, and you have to make sure they all mesh up perfectly, because if you don't, you will get an import error. So I just want to make sure people are aware of that when I'm coding. Okay, so once we've done that, we can import our libraries. There's a few of them, so it takes a little bit, but nothing too crazy. And then from here, this is kind of the fun part. So for those of you who are not aware, I had a whole series on building an API client library for TD Ameritrade Nice thing is we actually get to leverage this library inside this particular series. And so we're going to be using the API client in order to go get some historical data for a couple different ticker symbols. Now, because the library is not installed in the default locations that Python searches for libraries, if you try importing it, as you kind of see me do in the documentation for that series, you will actually get errors. And the reason why is because Python's searching for a library that it doesn't see. Now, if you have this library on your system, it's really easy to import it. The first thing you have to do is you do have to define a path to that particular library. So you can see here, this is the full path. Now, depending on if I'm on my work or on my personal computer, I do have different paths. And so all I do here is I'm just saying, okay, well, if I'm on my work computer, then provide the work computer path. If I'm not on my work computer, then provide my personal computer path. And then once I have that path, I call the system module and then the path.insert function, and I insert that path into my system. And so that's really important because once you do that, you can then import it as you normally would. And so from here, you can import your library just as so, and you should not get an error. Now, an FYI to some of you who do use Visual Studio Code and stuff like that, you will probably still have an IntelliSense error because IntelliSense, you have to explicitly direct where to look for external modules. I have not found a consistent answer as to how you do that. I've tried different things and sometimes they work and then sometimes it seems like they break the next time. So I'm still in the process of trying to figure out what answer is the correct one. Once I do, I'll kind of update people appropriately to let them know what they need to do. Okay, so that's inserting your path, and that way you can import the library as so. And once you've done that, then I have I would call it the meat of the data collection process. This is pretty much doing all the data collection process. But basically all it is right now is it's a function. So I create a Python function, and all this function does is the first thing it will do is it will create a new session with my TD API. So for example, if I don't have a session currently, it will create one, and then it will log me into that session. And that basically just means it authenticates me and it makes sure that I am who I am supposed to be and stuff like that. And once I have that session all active, I now move to the next step, which is defining the stocks that we're going to be using in our particular model. Now, you might be asking, oh, Alex, how did you come up with these stocks? And these actually are not the ones that the paper uses. I kind of just chose my own. And with these ones, at least how I approached it is I wanted, stocks that were kind of similar in size, but from different industries. So for example, I wanted like a financial one, so I chose JP Morgan. IBM, that's kind of more tech related. Personally, I probably would have done like Microsoft or something because IBM hasn't been doing super great lately. Arrowhead Pharmaceuticals, so now you get in that kind of healthcare component. Costco, so retail. And then Home Depot, which is also kind of like home improvement retail, so that's kind of like a good indicator, like housing markets and stuff like that. So I tried to pick stocks that were a little bit diverse. I didn't want, for example, I didn't want all finance stocks. Now, that doesn't mean you can't do it. You just have to kind of keep in mind that might impact the overall results of your model, and you might have to interpret it differently because if you're, for example, if you're using all financial stocks, it just means that you might not get the same results if you had just thrown in a retail stock, and I wouldn't necessarily use that same model for predicting retail stock prices or something like that. If I'm using all financial stocks, I would assume that you're probably going to be trying to predict financial stock direction. So just keep that in mind as you're building this model. But again, it is open to change. So basically I store each of these tickers in a list. I then initialize a new list that's going to be storing all my historical prices. And then what I do is I loop through each ticker in my list and I grab the price history. So what I do is I get the last 2 years and I get the daily data. So I get the daily price for the last 2 years. I do not get any extended hours. And, if you kind of think about that, I know the market's not open every single day a year, but, 365 times, 2 or whatever, you can kind of gauge how much you should be getting back. But this is all daily data, and it's for the last 2 years. Again, this is something too, if you wanted to change it, go right ahead. I'm not going to stop you. you just have to keep in mind it might impact a little bit the results that you get. So you just have to be aware of that. So once I get my price history, so once I make my request, I do get some information sent back to me. The portion that I am concerned with is the candles portion. So what I do is I go through the candles portion and I grab the symbol first because I want to have a way of identifying what symbol each of these prices belong to, and then I store all that information in a list. And then what I do is I take that basically list of dictionaries and I store it in a data frame. I take that data frame and I export it to a CSV file called pricedata.csv, and I do not include the index. So I basically just have the columns of information. I do not include the index column that you would normally see with a Pandas data frame. So this entire function is basically used for data collection, basically the data collection process. And then what I do is once I've done that process, you shouldn't have to do it again unless you want the latest data again. So if you want to, update it where you get the latest couple of days, I haven't run mine personally, I think in like 2 or 3 days, so it's kind of behind actually. But once I've defined this function up here, this little portion is basically checking one thing. It's going to check and see if I already have that price data.csv file in my directory, which if you do go there, you will see that I have it. And so if it's there, it doesn't call this function again. It just simply loads that CSV file and stores it in a Pandas data frame. So this basically just makes the code a little bit faster, where it's saying, okay, well, you already have the price data CSV file, so you don't need to make all the requests again. So I'm just going to use that CSV file instead. If that price data CSV file does not exist, then what it will do is it will actually call this function again, and then it will read that CSV file. Now, technically, I should just return the price data frame. I really shouldn't write it to the CSV file. But, I was just lazy and I never changed it. And when I was building it, that's just kind of my logic at that point. But yeah, technically you should just be able to return the price data frame. And then if you wanted to, you could dump it after that point. But, it's kind of up to you how you want to do it. Me personally, again, if I was looking back at it, I would just have returned the data frame. I wouldn't have gone through all that. So at this point, I should be able to run this, and you can see that it does load all my information, which is great. It means that it worked like I was expecting it to. And what we're going to do next is, now what I want to do is I want to reorganize the data a little bit, and then from there I need to do just a little bit of a transformation to get things ready to calculate some indicators. So the next couple things are more related to basically getting the data all set up. That's kind of how you need to think about it. So the first thing I personally like doing is I want to make sure my data is all organized. And so what I do is I want to make sure it's just in the proper order. Again, this is not really a necessary step. You could technically just skip it all together and you should be fine. But for me, I like making sure my data is in a certain order. So I want my symbol to be first. I want my date time to be second. I want my close price to be next. I want my high of the day to be next. I want my low of the day to be next. And then I want my open of the day to be next. And then finally, I want my volume for the day to be next. So all this is going to do is it's just going to reorganize all that data for me again. And so if I run it, you can see it's changed a little bit. So now our symbol is first, our date time is next, so on and so on and so on. So this is just me just reorganizing it. That's how you can think about it, right? Just reorganize the data. Alrighty, so reorganize the data. So for a couple of our indicators, well, one to be more specific, I mean, I guess it's used technically other places, but one of our indicators does expect a certain piece of information, and what it needs is it needs to know the change in price from one row to the next. So basically, did the stock close up or down compared to the previous row? So for example, if I look at row 0, this was my closing price for JP Morgan at this particular point in time. At row 1, this was the closing price for JP Morgan at that particular point in time. So it means it went down. So that means I want a column over here that will have the change in price from row to row. Now, while I create that column, we're not necessarily done right away. There's actually an extra step we have to do, but I'll get to that in a second. At this point, I just need a change in price column. But there's also one other thing I need to make sure. For the most part, the data should be sorted, but you shouldn't assume it's sorted. And if you're doing a price change from row to row, it's very, very important that the data is sorted because, for example, if it was like JP Morgan and then Home Depot and then JP Morgan and then Home Depot, you can't do the price change. So the first thing I need to do is I need to make sure that my data is sorted. So sort the data on symbol and then date time. So how do I do that? Well, I take my price data frame. I call the sort values method. I have an argument called by, which can take a list, and these are the columns that I want to sort by. So I first want to sort it by symbol, and then I next want to sort it by date time. If I use the in place argument, it will do that sort in place, and that means I don't have to reassign it to a variable, basically. It will just permanently change the data frame from this point forward. So sometimes in place makes sense to use, other times I don't like permanently changing it, especially if I'm going back and maybe using a data frame before I did a sort. But in this case, I'm okay with it being a permanent change. So once I've done that, I should see nothing super crazy because it was already kind of sorted to begin with, but it will be a little bit different related to your symbol. So your symbol is a little bit different in this case because in this particular example, A begins before J. So it wasn't truly sorted, but now it's sorted. All right, so next we're gonna do is we're gonna create a new column and we're gonna call it change in price. And that's gonna equal my old close column. So I'm gonna take my old close column and I'm gonna call the diff method. And so this will calculate the change in price and it will go row by row. So it will take the current row and it will subtract the price from the previous row. And if it's negative, and so on and so on and so on. So this is just a really easy way. This is kind of one of the benefits of Pandas is it makes this process of, what is the word, of doing certain transformations really, really straightforward and easy. So that's definitely a benefit to using Pandas. So I do want to print my data frame just to make sure it's all good. You can see right here that the first price value is non, which is correct because there is no previous price to compare it to. But there is a tiny little issue. Because my data frame contains multiple symbols, I do have to make sure that the first occurrence of each unique ticker symbol is a non-value as well. So for example, if I was to look at my JP Morgan one, you would see that the price difference is still there, but it's comparing to the last value of the ticker above it. That's not good. I don't want that. And so what I need to do is I need to remove those rows. Well, not remove, but I need to modify those rows so that way they are being calculated correctly. So this next step is basically fixing the issue that we run into when we calculate that diff column. So the first thing is I need to identify the rows where the ticker symbol column changes. So bear with me. I'm going to do my best to kind of explain what's going on. So the first thing I'm going to do is I'm going to take my price data frame and I'm going to call that symbol column. And then I'm going to do a comparison, not equal to. I am then going to take my symbol column again, but I'm going to call a particular method. I'm going to call this shift method, and I'm going to shift it down one row. And so what this will do is it's going to say, okay, here's my one column. Here's a copy of my column, but it's one down. Return the rows where they are not equal, because those are the rows where the ticker symbol has changed. So those are the ones I'm concerned with. Now, what I'm going to do after that is now that I've kind of identified them, and you can actually look at this, it's just a giant Boolean column. It's just a bunch of true, false, and all that kind of fun stuff. I need to basically change the values of those particular rows. I want to change that change in price column to a null value. So what I first do is I'm going to change the, here we go, change the change in price column to null. Or non, however you want to think about it. So I'm going to take my price data frame. I'm going to do the change in price column, and I'm going to set that equal to numpy where mask equals, and it has to be equal true. Once I've done that, then I want to specify what I want that value to be. If it is true, I want it to be a null value. And do I want to change everything, or do I just want to kind of change one column? Well, I just want to change one column. I want to make sure it's that change in price column, that change in price column. Once I've done that, I should be able to see all the null values. And so what I'm going to do is I'm going to take my price data frame, and I'm going to take my price data frame, and then I'm going to call the isNA method. So is it null? I'm going to look for any null values, and I want it to be on the axis of 1. So see all my null values, and you can see I now have all my correct values, and look, they're all the same date time. So I'm confident that it did the job it was supposed to be doing. So very important step. I mean, it's not, well, it's important. Let me put it like this. Is it probably going to dramatically change things? Maybe not, but it's a very important pre-processing step you should do, because technically you want to make sure that you're calculating it correctly. Now, the paper does a little bit differently. I think the way they were doing it is they were actually doing one stock at a time. I'm doing it a little bit differently in mine. I'm just doing it all at once. So be kind of interesting to see how the result changes if maybe I only had, you know, one symbol compared to all at once. Part of it is I kind of like trying different things and seeing what happens. And so, yeah, this isn't maybe following exactly to what the paper was doing, but I think it's a little bit interesting, and hopefully, you know, maybe we can gain some insights from it. So at this point, I am going to close off the video. We've done, for the most part, most of the pre-processing steps. In our next portion of the video, we're going to be calculating some of our indicators. So I'm going to do my best to at least give you some context as to what the indicators are doing, and then we'll show you how to calculate them. For a lot of that portion, I'm probably just going to be copying some pre-existing code because it is pretty similar, and then just walking you through how the code's working and stuff like that. So that's what you can expect in the next video. At this point, you got any questions, feel free to put them down in the comments below, and I will try to make sure to get back to you. Otherwise, we will see you in the next video.